This is part 2. And let's see, who or what is the creator or prime mover? This has to do with origins. Now in quantum physics, this character here, Werner Heisenberg, was one of the great contributors, and he found that the act of observation determines what the phenomenon will be. Prior to Heisenberg's time, there was a belief that the reality around us was completely disconnected from anything we could do about it. That we had no influence over the observation. That the phenomenon wasn't dependent on us looking for something. Now, this isn't what was taught in the Sermon on the Mount, of course. You know, seek and you will find. Well, in quantum physics, they were faced with the conundrum that if you look for the wave behavior of something, then you can find its pattern, its wave behavior. But if you're looking for the particle, the location, to see where it is, then the closer you get to finding out, determining exactly where it is, the less you know about its pattern of behavior. So the particle nature of things you find by looking for the particle nature. The wave behavior you find by looking for the wave behavior. And this has led into some very interesting and very puzzling approaches to dealing with reality. And for decades, even though this was clearly proven that we determine the phenomenon by being the observer or using our observational instruments, so we know whether something has, say, decayed in a radioactive decay. We know when it happened, you know, by looking for that. Now there's a great deal of difference between a wave and a particle. So how do you use this realization? And for decades, as I say, physicists just says, yeah, well, that's the way it is, but what does it mean? Today, I'm wearing one of these devices. That's something Arthur knows about. And I got this to deal with atrial fibrillation. It's in a certain sense, it's kind of like an external pacemaker. I can take it, put it on, take it off, go through airport security. I put it in the bin. And it's putting out a pattern of vibration. And my health has made some very dramatic changes in the past few months that I've worn this. Things that I never expected to happen. So I'm feeling pretty good, Arthur. I don't think I even told you this before. But yeah, well, it is a testimonial because, and this is quantum medicine. It's cheap, it's easy, it's like effective. Wow, is it effective? So I would have to say it's the future in medicine. And Arthur's one of the pioneers of this. So it's there's a lot coming down the pike on this. In agriculture, our company is called Quantum Agriculture because we're applying quantum physics to agriculture. Now this guy here, John Bell, he published his work on what he called Bell's theorem, or it was called Bell's theorem. And it's one of the very peculiar things about quantum physics. Quantum non-locality and entanglement. And that doesn't explain what it is. But what's going on is you can take a pair of particles and send one in one direction and one in the other direction, light years apart. And whatever you do to this particle is instantaneously reflected in that particle because they are entangled. And this is a phenomenon that occurs because quantum physics is dealing with the patterns of energy. It's more about the patterns than it is about the particles. It's what the particle is doing. And if in this pair of particles you switch the behavior of this particle, then that one switches instantaneously. We're looking at patents that are applications for patents on faster than light communication, because it's instantaneous. And in quantum physics there's something called superposition. It's neither on nor off until you make the determination. It's both and. And when you make the determination, when you make the observation, then it collapses the superposition. And so there's a great deal there that's involved we're going to see advances in quantum computing that'll be 1 trillion times faster than what we know today. So faster than light communication. There was a time when Carl Sagan said, if there was other life in the universe, we would have picked up their radio signals. Well, why would they use radio when it's limited to the speed of light? So that theory that we would have picked up their radio signals doesn't hold much water, because if a civilization arose that used radio, it would pass on to something else so fast that there wouldn't be any radio signals out there to pick up. It takes light years for these things to travel anywhere. Alpha Centauri, which is our closest star, is 4.5 light years away. So there's a lot going on there. This is one of the factors in quantum physics that actually Einstein called this spooky action at a distance, and he didn't like it very much. So Bell didn't publish his Bell's theorem work until 1955, which was the year that Einstein died. Here's another figure that looms large in not just quantum physics but in agriculture. And his approach to agriculture, his understanding of these things, was drawn from the big picture. One of the things that Rudolf Steiner realized, his early studies in the Technische Hochschule, which was the scientific institute in Vienna, were in mathematics, chemistry, and biology. He had a triple major. And the big deal in mathematics at that time was projective geometry, because it had been realized that there were other geometric systems beyond the Euclidean one. And particularly with the work of Bernhard Riemann. Riemann had published his work on a geometric system which was a parabolic geometry. So parallel lines converged and diverged in that geometric system. And it wasn't until right towards the end of the 19th century that that approach to mathematics was incorporated into mathematical physics, and this is what Einstein's relativity theory was based on. And many other things in physics. The debate in physics still rages today. Do we have an open universe or a closed universe? In other words, does it all collapse back in on itself at some point, or does it just keep expanding forever? One of these systems would be a hyperbolic system. The other one would be a parabolic system. Two different systems of geometry. And Steiner realized that for living organisms, we have to use both systems. And why is that? The reason is that life arises at boundaries. If you lost your skin, that's your boundary. If you lost your skin, how long do you think you'd live? How could you contain the organization, the vitality of your being if you don't have your skin? So everything outside your skin, which includes the sun and moon and stars, everything outside your skin is reflected within your skin. The organization of the universe is what informs your body. And so Steiner used this as an approach to agriculture that was completely, like even easily 100 years ahead of its time. Steiner asked the question, does consciousness arise from matter? Or does matter arise from consciousness? This is a good question, you know. We're talking about the origins of things. Where does it come from? And if you prefer one of these beliefs, a great number of people prefer to believe that consciousness arose from matter. Well, why would you believe that? You could believe that matter arises from consciousness. Just think about it, you know. You might choose to believe that matter arises from consciousness. It's a little bit different way of looking at things. Erwin Schrodinger taught his biophysics lectures in Dublin in Ireland in, I believe, 1948, shortly after World War II. Of course, he was no longer employed by the Third Reich. But he said that living organisms, this is just an observation he made, living organisms have the remarkable ability to concentrate a stream of order on themselves and thus defy entropy. Entropy is where the energy is lost, becomes unavailable, it leaks away, and everything runs down. And according to that belief, there shouldn't be such a thing as evolution. And yet you find some of the very physicists and biologists and scientists in general who believe that entropy rules everything, and yet they believe in evolution. And there's a big contradiction there, but somehow or other, they're not addressing that. You know, in our approach to science, where we have compartmentalized everything, and everyone is a specialist. And so, you know, the specialists in biology are saying, oh, well, you know, living organisms evolve. And the specialists on thermodynamics say, well, everything runs down. Does it? Does everything run down? If that was true, you never would have been born from your mother's womb, because everything would be running down. You wouldn't grow up to adulthood. You wouldn't accumulate the energy of soybean plant or a redwood tree, or any of those things wouldn't accumulate that energy. So it's pretty obvious, really, that living organisms have this ability to concentrate a stream of order on themselves, and thus to defy entropy. Now, they do that within boundaries. You do this within the boundary of your life, you know, your life cycle, your lifespan. It gets to the point to where you do run down. I've experienced some of that. But on the other hand, I'm still like learning, and I didn't know until just 2 days ago that stink bugs have an effect on corn, because the corn stalk is nice and juicy, and they come up and stick their proboscis in there and suck on it. And in that process, they produce a particular phenomenon, a disease in corn, and it's real visible if you see it in the field. And I didn't previously know what that was, but I found out just 2 days ago. It's stink bug damage in corn. Very interesting. So I'm always learning things. Okay, here's another fellow, Edward Lorenz. Lorenz was a mathematician at MIT studying weather and trying to work up computer programs. And this is back in the 50s. And with old IBM mainframes with the punch cards and the magnetic reels and everything. Huge computers that was twice the size of this room, that didn't have 1/10 of the computing capacity of my laptop.
They had tubes.
Yeah, they had vacuum tubes and all kinds of, it was amazing.
30 seconds mean time to failure.
Well, he was trying to work up computer programs to predict weather. And his computer crashed, and he had to put his data back in from his printouts. And it left out a couple decimal points, you know, way down in the 10,000ths area. And it completely changed the result. And he got to looking at that, and he discovered, now this is back in 19th century fluid dynamics, that Osborne Reynolds created a dictum that's still used in fluid dynamics today, that a microscopic change at a point can affect large-scale changes in the medium. And that's basically what this device here is doing. It's having an almost, you wouldn't detect it, sort of an effect. Mm-hmm. And yet, down the track, this builds up and builds up to where there's really profound changes occur. Now, Now, I've worked in agriculture to a great extent, and one of the big things is making rain. And how do you make rain? Rain is organization of the moisture in the atmosphere. If you can organize it strongly enough, you'll get rain. And to organize it, it just takes a little push. I can take my radionic instrument and give morning and evening treatments to an area and increase the organizational energy that produces rain. So making rain is not as difficult as you might think. We're actually spewing out, like automobile fumes, industrial fumes, etc., we're poisoning the atmosphere, we're degrading its organization, and we're doing it quite unconsciously, just as a byproduct of some of the things we do in civilization. So, rain in Atlanta, the Weather Bureau has published this information. Rain in Atlanta is 20% more likely on the weekend than during the week. 20%, that's big. It's more likely to rain on your barbecue than when you're going to work or coming back. Because all of that smog and pollution that's it's going on because people are commuting to work on the weekdays. And the atmosphere gets a little break from that on the weekend, and that's when it's more likely to rain. Well, if we're having that kind of effect on the weather, it's a negative effect probably. If we're having that kind of effect, why can't we have a positive effect? And we can. So that's a pretty significant part of this, of what we can do in quantum agriculture. Chaos theory. The theory about chaos is not whether there's chaos or not. There's chaos. But how come in the midst of chaos, order develops? And this is a proven fact, is that order arises out of chaos. And where the order arises is at boundaries. So, where we have matter, then we have chaos. And where we have what in the kind of agriculture I do is called ether, then we have order. So in the thermonuclear explosion, then we have chaos. Boy, do we have chaos. But the golden mean spiral, which is at the basis of all life organization, is the only self-similar number in mathematics. It's derived from the Fibonacci series, and it's called phi. It's like pi, but it's called phi. And it's a non-repeating decimal. It's what's called an irrational number. It's not irrational because it doesn't make sense. It's irrational because it can't be expressed accurately as a ratio. So you can't turn it into a fraction. It's a non-repeating decimal. You can approximate it as a fraction. You know, the Louisiana State Legislature, they had a bill introduced. Fortunately, it didn't pass. But they introduced a bill to change pi from 3.14 blah 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 to 3. to make it easier for the school kids. Yeah. There was a little more sense in the legislature than it took to pass that bill. So, but it's kind of an appealing idea. Look, how can you deal with pi when you can't even express it as a fraction? So, they were going to rationalize pi. So this self-similar number, which is 0.61803 or 1.61803 or 2.61803, depending on where you take your numbers here. If you divide, one of these numbers in the Fibonacci series, say if you divided 377 by 233, then you get 1.61803. But if you divide 233 by 377, you get 0.61803. And if you skip two numbers, then you get 2.61803 and so forth. So only number of that sort in all mathematics. And it's expressive of how life arises. Now, Steiner's approach to looking at these things, nature in general, was based on the work of Johann Wolfgang von Goethe. And Goethe, you've probably heard of as a playwright and a poet, and pretty much the nearest thing to Shakespeare in the German language. And Goethe he spent at least half of his time in his writings and whatnot on science, not on poetry or writing plays or anything else like that. He was a scientist. But he had a different approach to science than was popular at the time, and still different than what's popular today. So Goethean observation is based on looking at enough replications or enough different cases that you see the similarities, you see the synergy in things, you see beyond just the one instance that you're looking at. You know, when we take a test in school, there's only one right answer. If I was a school teacher, I would ask students to give me at least 3 answers to 1 plus 1, and to give me the reasons why each answer is valid. Just think about it. You've got a snake and a rabbit, a python and a rabbit. And so you've got 1 plus another 1, and pretty soon it's only 1. If you have a plus 1 and a minus 1, then the sum is 0. If you have 2 rabbits and 35 days, one of them is a male and one is a female, you'll soon have 6 or 8 rabbits. Even one kernel of corn can produce 200. So what we're thinking of in mathematics, the mathematics we learn in school, is just one part of the mathematical picture if we took it in its potential. So there's more to these things than what we thought. The fact that we use Euclidean geometry all the time. Every house we build and road we, build and so forth is based on Euclidean geometry. But if you were to shoot a rocket to the moon, if you tried to shoot it on a straight path, man, you can't get enough fuel in that rocket. You can't shoot a rocket straight to the moon. If you want to shoot a rocket to Jupiter, You shoot it at Venus, and you accelerate downhill towards the sun, towards the gravitational center of the system, like mad, and build up so much speed that when you sling around Venus, it shoots you out to Jupiter. Because you can't put enough rocket fuel in the rocket to shoot straight at Jupiter. So Goethe thought, well, in the mineral realm, what's the wellspring? What drives this? And in the mineral realm, he believed that the wellspring of nature was polarity. You've got positive and negative charge. You've got north and south magnetism. You've got left and right spin. You know, that's the basis of magnetism. And you've got up and down. These are the three things you cannot confuse a plant about. It knows. It's built to the specifications for positive and negative charge, left and right spin, and up and down gravity and levity. You know, when Sir Isaac Newton was sleeping under the apple tree and one of those apples fell down and hit him on the head and inspired him to write his theory of gravity, he didn't explain how it got up there. So actually there's gravity and levity. Now in the organic realm, Goethe thought there was a different driving force or wellspring of nature. And he found that in living organisms there's always a drive towards enhancement. Things grow, they reproduce, they evolve. That enhancement is the driving force in living organisms. Now, life arises at boundaries is really expressed in this particular geometric system here. This Benoit Mandelbrot was a mathematician working for IBM, and he had the chance with a computer to plot these different points in a mathematical equation that defined boundaries. So the equation was z is equal to z squared plus c. Very simple mathematical equation. So z is your variable. You put in different numbers there for z. If they're over 1, then you don't get anything. But if they're under 1, then you get a very interesting set of points, and it's called the Mandelbrot set. So you can look at this at any magnification. You can go on the internet and download this Mandelbrot set generator, and then you can look at it at any magnification, and it's always got this very organic sort of form that it creates. So it's kind of a fun thing to do with your kids. This brings us to the gateway between energy and matter. And hydrogen is the first amongst all the different elements of matter. It's simply a proton that's associated with the electrons in the universe. It's the simplest of all material things, substances. So hydrogen is where the spirit becomes matter. Matter is bound spirit. Spirit is matter that is freed. It's no longer locked into its location. So hydrogen here is obeying this phi principle there, the golden mean principle, and it's constantly like folding in on itself. It's like a vortex. And it's got several layers of electron association with that proton in the center. So hydrogen has the least content of any element and has the greatest boundary. And if life arises at boundaries, which it does, then hydrogen is where life arises. Your body, everybody's body here in this room, is way up there in the high 90% of hydrogen. There's a lot of hydrogen in your body. Everything that's working. See, water is the oxide of hydrogen, H2O. But hydrogen is 98% of all the matter in the universe, as far as we can tell. It's everywhere and in all things. It's like God. So hydrogen is a big deal. This is a picture out of a geometry textbook inspired by Rudolf Steiner. And when we're looking at the particle, we're looking at the content of something. If we were to look at these points, they are from the center, they are the radius of the circle. And the point is going around, it's all based on the center of the circle. But over here, you've got a different way of looking at the circle. This is a geometric system where those very same points are defined by tangent lines that touch those points. So this is defining the circle from its context rather than its content. Now this implies then that as a living organism, that the whole universe around you, all the, you might say, see what we do when we eat something is we're taking outer substance into our intestines and digesting it, and we're turning outer substance into inner substance. So what I do in the spring here in North America is the poison ivy starts to leaf out in the spring, and I'll pinch off a couple leaves and chew it up and swallow it, and I'll be immune to poison ivy the rest of the year. It used to be when I did this that I'd get a little scratchiness in the back of my throat, and you initially have a reaction, and by the time my stomach and digestive process got to work on it pretty good, then that would go away. And this is an approach to allergies that has been used in medicine to turn outer substance into inner substance, to teach your body how to accept something that it's trying to reject. So that doesn't mean that if you're allergic to pollen, you go out and eat a spoonful. No, but you might eat a grain of the pollen or take it homeopathically. Homeopathic doctors will take and make a dilution of that pollen and take it out to the point to where only the pattern is left in the water. There's no actual grain of pollen left. You go out to about 20 steps of dilution of 1 part in 10, and you've gone beyond any grains of pollen. But the water will still have the medium that you're doing this with will still have the pattern because of hydrogen bonding. And so you can give somebody the pattern without the actual substance, and then you get, your body will get accustomed to that pattern and won't be rejecting it anymore. And this is without actually eating the pollen. In homeopathic medicine, I use this in agriculture all the time. You know, if you were allergic to something, ptomaine poisoning, for instance. There's been a few times in my life when I've had ptomaine poisoning, and the remedy in homeopathic medicine is arsenic amalgam. That's white arsenic, or technically that's arsenic trioxide. But I'm taking 30C dilution. This is 30 steps of diluting at 1 part in 100. So it's a serial dilution and succussion at every step. And 30C arsenic amalgam is a very effective medicine at stopping anaphylactic shock. One day, it's just a Saturday, and we had a really good market down in Atlanta, and the person I was marketing with, we stopped in and ate. We treated ourselves to a fish dinner at the fish market in the north side. And I had eaten a few bites and got ptomaine poisoning. And my heart was going like this, and the sweat was rolling in my eyes. I was like puffed up and breathless, and didn't see how I would make it to Northside Hospital. I had a really strong reaction, something that I ate. It was shellfish. And I looked at the other person. She was eating her Chilean sea bass, and the juices were flowing down her throat, past her tongue, and she was really enjoying it. And I looked at her and I said, "I've just been poisoned." And she opened her eyes and looked at me as if to say, "No, don't do that." And so she said, "Think arsenic amalgam, 30C in your third eye, Bubby." And she tapped her forehead like that, and she grinned. You know, a fake grin. But it was a grin, like, you know, I'm going to keep on eating my sea bass no matter what the hell you do. And, and I thought, of course. And man, with all of the intention, you know, of any time in my life, I thought, arsenic amalgam, 30C, in my third eye. And my heart stopped racing, and I took a deep breath, and I went to the restroom, and, you know, I did everything. I emptied my bladder and had a bowel movement, and washed my face, and came back and sat down. I didn't eat any more of what was on my plate, but yeah, it was just thinking the remedy. You know, it was something I was familiar with, and as a chemist, arsenic trioxide, you know, it's what people used to poison people with. It's a slow poison, but not if you get enough of it at once. Man, it puts you right into shock. But by thinking the remedy, then it was that quick and that sudden. So this is a way of looking at these things. This context here is connected. These lines they go to infinity in both directions. And if you rotate such a line around the circumference of the circle, this is what you get, a circle defined by its context. We're not taught this kind of mathematics in school. But this is what's going on with living organisms. Your surroundings are affecting you. In epigenetics, this is the rule. It's called epigenetics because your genetics is actually affected by your surroundings. And genes are switched on or switched off due to the influences in your surroundings. And the better we understand that, the more capability we'll have in both medicine and agriculture. This is the way, see, Rudolf Steiner realized that your cations, the lime, like calcium is the leader amongst cations in agriculture, and the lime forces are working like this, see what you see here, but the silica forces, silica is completely neutral element. It's neither a positive nor a negative. It's able to accept electrons and it's able to share electrons. So silicon's reactions are all covalent bonds, whereas lime's reactions are all valence reactions. So what we see in the chemistry of things in agriculture is we see these two things operating together. So the silica, the capillary action, which is what draws the cations into the plant, it's what draws from the soil and builds the plant sap, and it works in the daytime. The plant takes up sap in the daytime and it loses sap at night. The sap sort of oozes out of the plant at its roots at night. So the capillary action in plants that takes the nutrients up into the plant is in capillary tubes, which are essentially lined with silicon. You know, if you had a capillary tube, it would be a little thin glass tube made of borosilicate glass. Borosilicate glass has a low melting point and that sort of stuff. But it's the boron in the silica lining in the xylem cells in the plant that takes the sap up in the plant. And silicon forms 4 bonds. It has 4 reactive electrons. Boron only has 3. So it doesn't take much boron in the silica lining of a plant to get the silica's 4th electron drawing on the stream of nutrients. And if you have too much boron, then you have to get more silicon in the lining because it's a ratio. So if you are boron deficient, this can lead to high blood pressure and cardiovascular problems. Because guess what? The heart is not a pump. The heart is a regulator. It has some pumping action because its function is a regulator. But if it had to force the blood through all these miles and miles and miles of capillaries in your body, then it would have to be much larger than it is. So to have that boron in your capillaries draws the blood through the muscles and through the tissues. This is especially necessary in bones. You know, bone cells are silica cells that are filled with calcium. So when you look at a bone cell in the microscope, it's six-sided like a crystal, like a silica crystal. And it's filled with calcium. The bone cells, calcium is working out from the center. The center is hollow, and the calcium radiates out towards the silica actually housing of the bone cell. You can see this in a microscope. It was in my biology textbook as when I was a sophomore in high school. The structure of a bone cell. It's actually a silica housing that's filled with calcium. You know, our skin, our hair, our fingernails, all of those things are high silica tissues. And our transport system, all our arteries and capillaries, our intestines, these are all silica tissues. They're rich in silica. Calcium doesn't get into the plant without the silica being there. So you can't develop strong sap pressure, and you can't have a real healthy plant without the silica. Fortunately, of course, most soils are over 50% silica. But unfortunately, actually it's very fortunate, this silica is nearly all insoluble. It's kind of like the nitrogen in the air. It's inert. And it's only available off the surfaces of soil particles. So sand, which is pure silica, is only releasing silica off the surface of the sand particle. Clay particles are aluminum silicate. But they're so much smaller, there's a lot more surface to the clay particle than there is to the sand particles. So in a clay soil, there's available silica, more available silica than in sand. So very fortunately, then silica is abundant everywhere you go on the earth. It's rich in seawater. Diatoms are highly siliceous, and diatomaceous earth, which has collected in a deposit on the bottom, is the old skeletons of diatoms. So, very fortunate that this is true. You know, this, just mentioning nitrogen, it's 78% of the atmosphere. It seems kind of crazy that we're spending more money on nitrogen than any other element in agriculture, when it's so abundant. Why haven't we learned to tap into it? Well, I can tell you one of the reasons why. There's no money in it for any corporation to sell you nitrogen if you could just get it free out of the atmosphere. So there's all sorts of nonsense that's taught in agriculture about nitrogen because it's commercially a valuable thing to teach people to buy it instead of just getting it. You know, we're taught that legumes fix nitrogen as if that was the only thing that does any nitrogen fixation in agriculture. Legumes make little nodules and protect the microbes that fix the nitrogen and feed them. And legumes will fix nitrogen in a soil that otherwise is not biological enough to do the job. It's not balanced enough. The legume can feed the nitrogen fixation under extreme conditions. But if you're looking at the plants that actually have the most nitrogen fixation going on around their roots, these are corn and sugarcane. These are plants that produce a lot of surplus sugar. And it takes 10 units of sugar to make one amino acid by biological nitrogen fixation. And it doesn't have to be in nodules around those plants. But it's never taught that way in our schools, at least not at this point. At some point it may be. But if you get your soil in the kind of shape to where nitrogen fixation is sort of an of course thing that happens, then, and this is true in my garden, I don't apply nitrogen, I get it out of the atmosphere. And nitrogen fixation is taking place around the roots of every plant that's giving off a good amount of sugars in its root exudates. So every kind of plant can feed nitrogen fixation. And they do, and nature has done this for millions of years, and it's only the last 100 that we've been putting artificial nitrogen on crops. To get a little bit better understanding of how this interplay between the silica and the lime work, then you can look at these pictures here. And this is a further elaboration. These are pictures from The Plant Between Sun and Earth by Olive Witcher and George Adams. And these are drawings to show how nature works. It's a geometry text, but it's got these really cool pictures in it. So, Rudolf Steiner, Anthroposophy, this is his agriculture course, which he delivered as his last major lecture cycle before he died. And it's really, really profound. His agriculture course was just a thin, a set of 8 lectures. But what preceded it was his medical lectures, which were a total, took place over a course of 3 years, was a total of somewhere around 30 lectures. So if you wanted to understand the agriculture course, it would be a good idea to study his medical lectures. And they're available, you might write this down if you're writing things down, they're available on audio if you go to Rudolf Steiner Audio, just all one word, put it in your search engine and go to Rudolf Steiner Audio. They're downloadable for free. Donations appreciated. And it's really, really profound in both medicine and agriculture. So your formative forces, these are the forces. You've got physical elements in the soil, just without any life in the soil. You have these physical elements. And you have physical elements in the atmosphere. You've got oxygen and nitrogen and carbon dioxide. And we have a few other gases in the atmosphere that are there, a tiny percentage. I think we've got about 3.5 parts per million. Is it parts per million? 3.5% carbon dioxide in the atmosphere these days. Which means that we've got a little less oxygen and nitrogen by proportion. But it runs about
400 parts per million.
About 78% nitrogen and about 18% oxygen in the atmosphere. These are the most important elements, in fact, because your body is made up of just a tiny proportion of things like iron and calcium and silicon and so forth. Nearly everything in your body is coming from the atmosphere. The carbon, the oxygen, the hydrogen, the nitrogen, even the sulfur. There's a sulfur cycle. So those physical elements is a part of the picture. But when you get to plants, then you've got the ethers. These are associated with what we called in an earlier age, we called the elements. Back in the 14th, 15th centuries and whatnot, The elements were all considered to be fire, air, water, and earth. And the organizational principle in fire is warmth. The organizational principle in air is light. Air is a perfect conductor for light, but not water. The organizational principle in water is sound or tone. And chemistry is based on the vibrational tones, the harmonies, the dissonances in tone. You know, whales can hear other whales 1,000 or more miles away in the ocean, and they can pick up on who it is and where they are just from tone. Whale music or whale songs are really amazing. But the one thing that plants don't do is they don't internalize digestion. Plants, the digestion that feeds plants is all going on around the plant. This is why your earthworms, your ants, all those sorts of things are so important in agriculture, because it's the digestion going on around your plants that feeds the plant. The plant is stuck in one place, and that's going on around it. But with animals, even your amoebas, your protozoa, they take in what they're going to consume and they digest it. And this means that they get their nitrogen broken down to amino acids before they absorb it. Now, our bodies, we think, you know, what's in our bones and whatnot, that it's just going to stay there. Wrong idea, actually. Everything in the whole universe is vibrating all the time. Everything is oscillating. Your etheric organization, the warmth, the light, the tone, and the life in living organisms, those things are just a little bit, because of the vibration, the oscillation, it's a little bit bigger than just the physical elements, because they're oscillating. And here's an experiment you've probably seen. You take a sheet of metal or whatever and suspend it or put it on a pin and scatter sand over it. And then take a tuning fork or some other source of sound vibration and make it vibrate. And the sand all dances into a pattern. Well, that's what's happening in our body. What's happening with the elements that are making up our body is they're dancing to a pattern. And they come free of that pattern, and other ones take their place. So every atom in your body is traded out for another atom of the same kind at least every 7 years. There won't be a single atom in your body that is still the same atom in 7 years from now. Everything is dancing. You could say that the universe, that the world we live in, is much more of a dance or a song than it is something that's a physical, like location, object, stationary. Everything is in motion all the time. Then, so animals, though, when it comes to this, nitrogen is the basis of awareness. So animals internalize awareness because they're getting their nitrogen and building up their proteins from within their own organization. And so they internalize consciousness. Now a cow is conscious. Boy, are cows conscious. But they're not conscious that they're cows. They don't have any awareness of themselves. They have awareness of the things around them. But they don't differentiate those things from themselves. It's only human beings, so far as I know, it's only human beings that do that they're self-aware. Human beings are aware of their own awareness. Now the fallout from that is human beings are always driven to try to become more than what they are. A cow is just being a cow and not trying to be anything else but a cow. But we human beings try to be more than what we are. If we're evil, we try to be more evil. You know, if we're saints, a saint has to keep trying to be saintly. You know, the word for a holy man comes from the same roots as if it was spelled W-H-O-L-E. If you had a hole in your bucket, you never have a half a hole in your bucket. It's always a whole hole. So there's like what integrity is all about. So these are the formative forces. There's physical formative forces, etheric formative forces, astral formative forces, and egoic formative forces. So 98% of the human body is coming from the atmosphere and only 2% from the soil. And that's the end of that section. I think we ought to take a little break.